Hello everyone. Okay, in this video, I am going to talk about Born-Haber cycle. So I'm going to divide this topic into three short videos. And the first one is the introduction. The second part is how you're going to draw the energy cycle and the energy level diagram. So let's start with the introductions of Born-Haber cycle. So basically, Born-Haber cycle is another way on explaining uh, the relations of certain enthalpy with another enthalpy, and it is always related with Hess's law. Okay, but in this time, usually in Hess's law, you see about like 2 or 3 steps, but this one involve 4 to 5 enthalpies. So you are going to see about it. Now, in Born-Haber cycles, you're going to see these 5 enthalpy. So we have enthalpy of formation, we have enthalpy of atomization, ionization energy, electron affinity, and lattice energy. You learned before what is enthalpy of formation, atomization, and lattice energy in the previous class and video. Ionization energy, you learned it actually in chapter 3 last semester, and also electron affinity, but I will just explain to you what it is. But for now, I just want you to remember that in Born-Haber cycle, we only talk about these 5 enthalpy, okay, no other enthalpy. So the formation, we have F, we have atomization A, we have ionization energy, which is I, electron affinity E, and lattice energy L. Fail. Okay, just remember these 5. Fail. So let's go one by one first. I'm not going to talk about what is formation, what is atomization. I'm going to focus on the other 3, which is ionization energy, or IE, electron affinity, EA, and lattice energy. So back to your notes. Okay, so let's see lattice energy. Just as same as in the video of Hess's law. So lattice energy is energy release when 1 mole of solid ionic compound is formed from its constituent gaseous ion. So as you can see like this, okay, we have sodium ion gas and chloride ion gas, and when these two, gaseous ion and gaseous ion, they combine together, they are going to form ionic solid. Again, the word lattice means ionic solid. Okay. Now, what factors affect the lattice energy? You should know this factor. Okay, we have 2 factors. The first one, the ionic charge. So when the ionic charge increase, means the ions attract each other more strongly. So the lattice energy will be big. And the second one is when the ionic radius is decreased. Okay, the smaller the ionic radius, you can relate this with chapter 3 that you learned before. The closer it is, okay, the ion will get close together. So when the ions get close together, they have a very strong attraction, and therefore we need more energy. Okay, more energy will be released to produce this. Okay, now if you forgot about this, just remember this relationship. Okay, so you can say that when ionic charge increase, lattice energy decrease in lattice energy increase. But when but when ionic radius decrease, lattice energy increase. Okay, you need to know these 2 factors. Okay, so that is lattice energy. So let's go through again one by one. Okay, so maybe I think you can read more about this. It's just that if you compare with these 2, let's make a comparison. As you can see, sodium ion and magnesium ion, we know that magnesium has higher charge compared to sodium ion. And then if we compare with the fluoride ion and oxide ion has more charge, and you can see the difference of the enthalpy, the lattice energy. Okay, so between magnesium oxide and sodium fluoride, you can see that the lattice energy of magnesium oxide is bigger compared to the lattice energy of sodium fluoride. And you can read the explanations here. Okay. Okay, this is like what I explained to you. The smaller they are going to get close together, and the attraction forces will be increased. Okay, so this is it. Now, I would also like to talk about this. What is electron affinity? Okay, what is electron affinity? It is about the heat change, which means it can be positive and negative. When one mole of gaseous atoms, bila satu mole gaseous atom gains 1 mole of electrons to form 1 mole of gaseous ion. What is the meaning of this? Now, let's see this one. Actually, you learned about this also in chapter 3 before. So, we start with oxygen gas. Okay, we have this. This is gaseous atom. Gaseous atom, and then it gains 1 mole of electron to produce gaseous ion. Okay, so for these reactions to occur, it needs to release 142 kilojoule heat. Okay, so this is what we call first electron affinity. First electron affinity, it's always starts this. Okay, I explain in Malay as well. Okay, untuk first electron affinity, mesti bermula daripada gaseous atom. Sebab sebelum sesuatu menjadi ion, dia mesti dari dari atom terlebih dahulu. Dan dia mesti dalam bentuk gas. Kemudian, okay, for second EA is when this one, the gaseous ion just now, okay, this one, which is this one, get another mole of electron. So in this phase, this is already gaseous ion. Add another 1 mole of electron, then it will produce O2 negative. Okay, so this is gaseous ion. So the enthalpy involved, as you can see, this is positive 844 kilojoule, means it absorbed 844 energy. So that is why for EA, we specifically use heat change. Because usually first EA will be negative, second EA will always be positive. Okay, how about third EA? So if you want to think about third EA, this one accept another 1 electron. And sampai habis. Okay, so like oxygen, it has how many electrons? It has 6 electrons, right? Okay, so from the 6 electrons, okay, overall it will have up to 6 EA, like that. Okay, so that is EA. Ionization energy is another way around. Oh, before that I forgot. EA produce negative ion. Okay, sebab dia gain electron, so it produce negative ions. But ionization energy is the energy when positive ion is produced. Same thing. Okay, as you can see, like first IE, we will start with gaseous atom as well. Okay, gaseous atom, but it removes 1 electron. So to remove 1 electron, we need to absorb energy. Okay, it needs Okay, energy required to remove 1 mole of electrons from 1 mole of atom in gaseous state. So, if it's first memang akan berasal dari gaseous atom, it removes electron to produce Mg plus. And then second IE, it must be from Mg plus, remove another electron to produce Mg2 plus. Okay, Mg2 plus. All right. Oh, then I remember. My example just now is wrong. The one that with 6 electrons. That one is actually meant for ionization energy. If you still remember, okay, I tried to make you remember. In chapter 3, we remove the electron, like 1, 2, 3, then 1, 2, 3, 4, 5, 6, 7, 8. Okay, like this, if you still remember. So you remove this first electron, you remove second, third, fourth, fifth, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13. Okay, and then there's a high jump over here, which means it comes from another shell. That is the IE that you learned last time. Okay, so I really hope you can remember that. So what is bond energy? Okay, bond energy, the energy required to break 1 mole of molecules into their individual atom. Okay, ini rarely come out in exam, but you just need to know. Okay, so again, I make a conclusion. Ea when negative ion is produced, IE is when positive ion is produced. Okay. Okay, so I'll stop here for because I want this to be as introduction only. Then in the second video, I will explain about energy cycle. All right.